I want to thank Adam and the rest of the board for inviting me to give this presentation today. I'm excited that we have, 45 minutes to an hour of time so I can cover the broad range of topics that we have. Generally, a lot of the talks you'll hear from the SPC are 15, 12 minutes at conferences, a quick overview of what we're doing. We have a little bit of time to delve in a little deeper here today. So I'm excited for that. So I'll go ahead and get started here. Adam covered it pretty well with my background, and I'm a mesoscale system and fire weather forecaster. We'll touch a little bit here on what that means. And one thing that I do want to touch on is I'm running on a basis that everyone on this presentation at least has a baseline understanding of the SPC. I apologize if there's anyone who doesn't. There might be a few things that I kind of skip over, but for the most part, I'm assuming that most people use or at least understand the SPC probabilities the majority of the time. So just a quick overview, our forecast, we do tornadoes, thunderstorms, wildfires, and we do anything from 8 days out all the way to a few minutes in advance. And the team here is got a lot of experience. That's something we'll touch on here. And then also, we work with all of the local National Weather Service offices on a daily basis. We're always interacting with them, and that's a crucial part of our partnership. So here's a quick overview of the operations area. So this is the operations area of the SPC. You can see we've got mainly 6 desks here, 1, 2, 3, 4, 5, 6. And I'm briefly going to go over what each of the desks do. Just for anyone who hasn't been to the Weather Center to get a tour of the SPC, this is what it looks like. So the lead forecaster is sitting here over at this desk, although not in this picture when I took it, but generally that's where the lead forecaster is sitting. This is kind of a look at what their workstation might look like with a watch drawn up, things like that. This is John Hart here. He's actually on the lead desk today, might even be wearing the same shirt. I'm not exactly sure, but he is one of a team of people who really have a lot of experience at the lead forecaster desk. So this chart here shows the amount of experience in the red line is at the lead forecaster desk itself, and the gray line is the total experience at the SPC. So you can see here in 2019, the lead forecasters have over 100 years of combined experience at the SPC, and at the lead desk itself, close to 45 years of experience, and that's amongst 5 lead forecasters. So that really leads to over 20 years of experience overall, and right around 10 years as a lead. And that really is crucial to our operations, and I think that's a big reason why we've had so much success is really the experience and the pure number of severe weather events that have been seen by the leaders of the shift. Jumping over to here's the Outlook forecaster desk. So that desk handles things such as the on the day shift they'll do they'll start out with the day 2 outlook that comes out at 1730Z, and then at 20Z they'll do the update to the day 1 outlook. They're on the evening shift. Their primary mission is to first update the day 1 outlook at 1Z, but then also do the new day 1 at 6Z. So that's for starting the next day at 12Z. And then on the night shift, that desk handles basically all of our extended range outlooks. So they do the new day 2, the new day 3, and then the extended day 4 through 8 is all done on that shift for the overnight period. Switching around to another desk here is the Mesoscale forecaster desk. And on that desk is generally where their primary goal is just to issue MDs. And so they'll be doing surface charts. This is actually, I took a picture of this morning. This is Roger Edwards' surface chart from this morning. And don't be concerned if you can't understand it, because none of us can either. Most of the reason we do these is for our own analyses, and nothing shows that more than Roger's charts, because he gets a lot of information out of it. The rest of us look at it, and it just looks like a bunch of lines. But we all do a surface chart to start our shift on most days, and on days when the weather's really busy, we might be doing several per shift. And that is really the core of digging into the data, which is the root of where mesoscale discussions come from. And that's the primary goal of this mesoscale forecaster, is to get those mesoscale discussions out, prepare the lead forecaster for what's coming up later on in the shift as far as watches go, et cetera. The one job that they do have on a routine basis, rather than everything else, is the thunderstorm forecast. So they do the 13Z thunderstorm forecast at the end of their midnight shift. And that's this product here for anyone who hasn't seen it before. So jumping to the next desk here is, right over here is where the Mesoscale assistant forecaster sits. And on that desk, their goal is to be supporting the Mesoscale forecaster. So also, this is my surface chart this morning, which you can tell looks a lot different than Roger's. They're all unique in their own way. But here's example of another Mesoscale discussion that we do on this desk, and that's in support of the Mesoscale forecaster. But there are a few more routine products here. So the 1630Z outlook, the thunderstorm forecast for that is done by this desk, and then also for the 6Z new day one outlook, that's also done by this desk on the evening shift. And then also at the end of the evening shift, the day one and the day two fire are also done on this disk. So that's why it's a cross between severe and fire, because there are duties for both. And so that takes us to the next desk here, which is the fire weather forecaster. They generally sit back in this corner. And on the day shift, they'll do, or it's only a day shift position, and they'll do a day one fire outlook, a day two fire outlook, and then the day 3 through 8 fire outlook. And those are due at 17Z, 20Z, and 22Z, respectively. And finally, this desk over here is one that we've recently started staffing full time, and it is really covering some of our more experimental things that we're trying. This is some of our more temporal guidance we're trying to add to our forecast, and we'll touch on that in a little more detail here in a few more slides. But then also that desk will handle social media, Facebook and Twitter. We're trying to be a little more active about posting there rather than just having auto post, things like that. We're trying to do a little better job of posting better graphics with maybe a little bit more information and things like that from our national page. So moving on here, here's the current look at the forecast and warning continuum. You can notice here, this is the uncertainty, which is obviously much larger out in time. And really the SPC encompasses a lot of this area here, the outlooks down to the watches stage. And here where I've drawn this line, this is where it for the most part goes down to the local forecast office's hands. And so it kind of gets passed from us down to them as we go through time. And if you've heard this term facets thrown around, it's really working towards a continuum to really through time have a consistent pace, a consistent update, and also having things like our forecasts have been probabilistic for a while now, and there's talk of doing that in the warning phase to really figure out how we can use probabilities to help, rather than just a black and white decision. And that's just because, the atmosphere is chaotic. We all know that. And so, probability is the best way to kind of explain some of the chaotic nature of the atmosphere. And so just, showing just how tough it is to kind of forecast this, here's a look at, or a couple different charts to look at how tough this problem is. So here's a chart of all tornadoes. Along the x-axis here is ML Cape, and along the y-axis is 0 to 6 kilometer shear. Now, around half of all tornadoes happen in this basically low Cape parameter space, and so that can be difficult. Well, also, when we're looking at significant tornadoes, 98% of significant tornadoes happen in this relatively high shear, right around 30 to 35 knots a shear or higher. That's where 98% of your significant tornadoes are happening. So here's a look at lightning hours, but when you overlay those two boxes there, the majority of where the lightning occurs is also where we are having these difficulties, or is where we get a lot of these tornadoes occurring. And so obviously every storm is not producing a tornado, so that's where we need to start discriminating. So here's a conditional probability of tornadoes. Obviously higher probability with higher Cape and higher shear. It kind of makes sense. The upper right corner is basically off the charts. Down here you have no Cape, no shear. So it makes, this chart makes sense the way we would expect it to look. Overlaying here, this is basically your 60% probability of a detection for a tornado watch. And if you overlay that then here with this is the mist tornadoes. So the mist tornadoes are happening down here in this, relatively high shear, low Cape environment. But if you overlay that with where our good POD and our false alarm rate is, there's definitely some overlap through here that we could see here in this chart. So I'll move on here to the next step. So this is, I liked this graphic. I took this one from Patrick Marsh, who kind of compared it to, in baseball, you've got your strike zone, your heat map. So in this area, these are the ones that you should knock out of the ballpark. The cool zone, those are the ones you might swing and miss. And the key here is we've got this area here, and this is where we spend a lot of our time, and that's a difficult place to forecast. So where do some past events look on here? Well, here's Palm Sunday, April 11th, 1965, well into this area that, really high shear, pretty good instability. Here's another one here. This one, that's April 3rd, 1974. The next one you might find interesting. This is April 27th, 2011. It's interesting how clustered these are. They're both kind of right in that, pretty strong instability right around 3000 Cape, and a very strong shear environment there. Here, this one's a little lower on the shear, but a little higher in the stability. That's May 3rd, 99. So overlaying for the past, 4 to 5 seasons, here's a lot of the major outbreak events. And so you can see a lot of them are here in this zone, and we do a pretty good job forecasting these events, but there are some of them that are hanging out here in this zone. So I say all that just to say that probabilities are really important for our forecast because what we've done is we've basically had our risk communication linked to science-based threat probabilities, and we've been doing that for quite a while, and that's really an important part of what we do, because if you're thinking about it, the atmosphere is not black and white. So if someone asks a question, will there be a tornado where I live today? Well, the answer is not yes or no. It's somewhere in between on any given day. Now, if someone's wondering if their house is going to be hit, you can say no and be right 99.999% of the time, but that's not very helpful to people. So it's really more of a probabilities. And so we really need to figure out, this gray area here, where does it fall on the spectrum? But then even more than that, to say exactly if it's going to hit someone's house, it's just we don't have the predictability for that. That's a very difficult thing to quantify. The fact that a tornado strikes a few miles away from someone's house still may be the perception that it was near enough for trauma, things like that. So will there be a tornado within 25 miles where I live today? That's essentially what our probabilities are showing. And so what's normal? Well, if you take the peak for early May, the peak is 1.4% each day, and that's right here in central Oklahoma. So this is, for right around May 6th. So you can see it peaks right around here. So that would imply that on any given day, there's a 1.4% chance that you would have a tornado within 25 miles of your home. Anyone who lives in Oklahoma knows that that's the case in the month of May around here. So what the SPC has done is broken these probabilities down into our categories of marginal, slight, enhanced, moderate, and high risk. And so that's where our probabilistic severe weather outlooks were born, in this idea of probabilities and that being the best way to display this forecast information. And one thing I want to note here is that our outlooks are statistically reliable. And actually, when you look at the numbers, they actually fit pretty well. So this is looking at our day one outlook, and this is from the 6C outlook. And so if you're looking at our forecast, the probability, if you want to be reliable, you want to be in this highlighted light green area. So you can see our tornado, wind, and hail are pretty reliable. Day 2 and 3, maybe slightly under forecast, but still pretty close to reliable as well. One interesting thing, it looks like tornado might be a little under forecast here, but when you take out EF0 tornadoes and you look at EF1+, which is this purple line, we're right there in the zone for reliability. So the only reason we might be slightly under forecast in the all tornadoes category is for the very weak EF0 tornadoes, which generally have pretty minimal impact or impacts that are similar to a severe thunderstorm. And so, that's probably something that we're willing to take, or that might go through a forecaster's mind when they're working on probabilities in that regard. So that goes over into the watch spectrum as well. We're actually pretty reliable on our watch probabilities for tornadoes, for hail, for wind. Those all match pretty well. And so I wanted to talk about a little bit of interesting work that Jared Geyer just presented at the NWA meeting here a couple weeks ago. And he was looking specifically at impacts based on our watch type. And so, for example, the number of tornadoes per watch. So looking here at EF2 tornadoes, for example, there are about 0.04 EF2+ tornadoes that occur in a severe thunderstorm watch. In a tornado watch, it goes up to about 0.44, whereas a PDS tornado watch, you get 4 EF2+ tornadoes per watch. And looking over here on, what type of impacts this has from a fatality perspective, when you go from basically 0 killer tornadoes that happen in severe watches to almost 1 killer tornado per PDS tornado watch, And the percent of watches with a deadly tornado, this goes from 0.4% in the severe all the way up to 28% when you've got PDS tornado. So our watches are very good at discriminating between severe and tornado, and then even more on the PDS tornado watches really discriminate from even just the general tornado watches. The number of fatalities per watch, this goes up exponentially as well. We're averaging 3.5 fatalities per PDS tornado watch. So this just stresses the importance that when there's a PDS tornado watch out, how serious of a situation it is. And when we say, particularly dangerous situation, that wording just about matches, what we're seeing in the stats, that it really is a dangerous day. So here's a way to look at it through time. So through the decades, it really has come out that there's always been this discriminating factor, but really since 2010, it's been a lot more exceptional. The number, and this is using just F3 plus tornadoes, so really the violent tornadoes, and then including F3 as well. You can see that there's a lot more tornado watches per PDS watch here in the more recent time frame. And so when you look at these, you're talking basically an order of magnitude more F3 plus tornadoes between a severe and a TOR. And then when you go from a TOR to a PDS TOR, it's almost another order of magnitude higher that you have. So there's very significant discrimination between each. So so part of the reason why our forecasts are pretty statistically reliable is because a lot of the tools have been generated. There's a lot of time spent here post-event looking at what went wrong with an event. Or, I think the first thing most forecasters do when they walk in the next day is they look at the previous day's forecast and say, all right, how did I verify? Was I running hot? Was I running cool? How was I looking on that? And so we have a couple ways to look at it. Here, there's a probabilistic outlook. So this is essentially taking the probabilities verbatim as they are. What was the grid coverage? How does that verify based on our probabilities? This subjective outlook, this is more just, you're looking at the dots, the red dots, the blue dots, the green dots. Okay, does that match the idea of what I would expect to see during say an enhanced? Does this look like the number of dots I would expect to see for an enhanced, etc.? And so because of the reliability of our forecasts, it really has been used widely across all industries. It's used by weather service offices, it's used by media, we see it on social media, and most of the time, I think this has really been a success of the weather industry, that we're all using pretty similar probabilities. There aren't different lines or different outlooks. For the most part, across the industry, we're all using a pretty similar message and pretty similar outlook that we're all messaging, and I think this has really helped in the severe weather forecasting realm. So along the lines of those graphics, you have to give a shout out to Patrick Marsh for these graphics that he's created. They really are really visually appealing and really helpful for social media graphics, etc. And he's got these broken down for by FEMA region, by local forecast office, by states, and some of the things that have been improved on it. You notice this goes beyond the state boundaries, because that was one of the biggest complaints we were getting from emergency managers, things like that. From the local forecast offices and even from national centers, in graphics such as these, well, it cuts off at the state line, and the weather doesn't stop there. It implies that it stops at the state line, even though that's not the truth. And so having this type of visual look really does a great job of showing, okay, this is an Alabama forecast, but if it continues beyond here, if you live in southern Tennessee, you need to go to your local state or local forecast office to get additional information, because you're still in the same category as the rest of northern Alabama. Things like that. And Patrick's continuing to work to improve these graphics rather than just having specific CWA and state and FEMA regions. He's working on graphics more like this that can be modified based on the outlook area on any given day, zoom in, zoom out, to be more focused on where the actual severe risk is, rather than just, static images for specific areas at any given point in time. And so with that, we do have a FEMA partnership here. Summer Erickson, she's our FEMA liaison here at the SPC. She's out on the operations floor, especially in April, May, June, several times a week, asking us about the forecast, because they've got some high-level planning decisions to make as an agency. And so we've worked really closely with them. That's part of the reason why we've got the FEMA-based graphics, because those are great for them to use for briefings for each region, et cetera. And so I want to kind of use the February 23rd, 2019 Columbus, Mississippi tornado as an example to show some of the temporal guidance that I showed earlier, to kind of show how we use that and how that works. So back on this day, there were a cluster of tornadoes that were here from far eastern Mississippi into western Alabama. Most notably, there's the tornado that went through Columbus, Mississippi. On that day, it was a 10-mile long tornado, about a quarter-mile wide. And this was the one EF3. There was also an EF2 that day and 4 EF1s, with 1 fatality and 19 injuries total for the day. So looking at what's normal, well, that's basically smack dab in the middle of where you would expect there to, if there were tornadoes, where you would expect them to be that time of year is right there. Although the probabilities you can see are still relatively low compared to what they were in central Oklahoma, still 0.4 is pretty high, and they're really starting to ramp up into their season by late February and especially into March down in that area. And so our outlook covered it pretty well. The center wasn't exactly there, but that was still within the moderate risk area. And so there's a 15% tornado outlook, and this is where the tornado occurred, right down there. Winds and hail, you can see down here as well. So when we took this outlook, and something that we've done is used basically background algorithms to calculate out the timing information. And so essentially we draw the lines the way we always have for this outlook. And then we use the href members, and we use the probabilities of UH, of updraft helicity. And when we use those probabilities, we can actually use that to get timing information. And so using that with basically using our probabilities that we've put in the outlook, these are the probabilities that we get that run from this forecast. So you can see on this day, it did a pretty darn good job. You see the red dots are the tornadoes, and so it really maximized right around the peak there, and was a pretty good case, because this is pretty early on that we had just started using some of this guidance, and it was promising to see that it did such a good job, especially because drawing an outlook for every hour for a 4-hour period for an entire day is it's not something that we can do as forecasters. So utilizing the href guidance to be able to, use an algorithm that can take what we've done manually as a forecaster and then create something like this without a bunch of extra work is really hugely beneficial to us. And some of the information that we can get out of there is stuff such as, what's the earliest reasonable time of slight risk probabilities get into your area? Or some of the other things we can look at here, we've got a chart that can show when the probabilities peak. And so it's color coded here based on when there's slight risk, when it's enhanced risk, when it's moderate risk, etc. So this is from the 13Z outlook. And see right here, this is when the tornado occurred. So it's towards the latter end of this, but still within the peak. But if you actually go to the 1630Z outlook, this would have included the 12Z href guidance, and that really zeroed in on the time. You can see the EF3 occurred right in the center of where this peak was. And so really it just shows through time, utilizing more and more recent guidance, we can really hone in on really when the highest risk area is. And so, this shows where the wind's at and the hail is at as well. Some things you might see here, like for example, the hail is pretty much, flatlined here. Part of that is what we've done is we have the href probabilities max out at whatever our outlook is. So for example, we don't want, if we have a 15% tornado probability, we don't want the href probability saying 25 to 30% and showing a higher probability than what we forecast. So the probabilities are capped at the max forecast probability from the SPC forecaster. So it's still driven by the forecaster, but we're utilizing the computer model to really help get out some of this temporal information without much extra workload on the forecasters. So some of the things that we can possibly do here in the future, the Warn on Forecast program has things such as 4-hour forecast supercell threat. And if we can include some of this temporal information from our outlook and include some probabilities such as this, we can really ramp up these probabilities. Because yeah, let's say it's a 15% probability, but it's a 15% probability because we don't know exactly where the storms will be. But if the probability is, let's say 60% that there's going to be a tornado, or that there's going to be a supercell thunderstorm in your area, and you're in, a very good environment, these probabilities are no longer 15. There's a much larger peak. And so, this will probably be several years down the road, but these are the type of things we might be able to do in the future with some of this temporal information, is really be able to, really zero in on when the peak probabilities will be and just how high those probabilities might be as well. So here's a look at the web page that we have. So this is currently available for all forecast offices. So it's internal to NOAA, and we've had forecasters looking at it and giving us feedback. We look at it daily as well. And one of the other possibilities that we've done with this is we've added the possibility to do experimental upgrades or updates to the outlook. So, let's say between 20Z and 1Z, it's a 5-hour period. We don't get a new update until 1Z. Well, let's say if things really look like they're changing, 22, 23Z, there's a bow echo developing, and we think the wind threat is going way up. Well, we can increase probabilities in between those outlook periods. Now, in the past, we have done that. We've amended outlooks when we thought it was very necessary, but this is really looking at the idea that maybe more often we can be better about putting these amendments out there when the environment's changing during these periods. And so that's one other thing we're doing here. But here's the web page that we have now, and it's great for looking at past events. Also for the current events. And we've gotten some pretty good feedback so far from forecasters that they're able to use this data to really help. For example, an emergency manager calls and says, "Hey, I need to figure out what time I need to staff my emergency operations center today." Do I staff it at 10 a.m. and have it staffed all day, or is it this not, like, for some areas, okay, no, the threat's not starting until after 9 p.m. Let everyone stay home and rest, and don't start ramping up until 5, 6 p.m. That's really valuable information for those people, because when I was working at a local forecast office, I remember a day where an emergency manager called our office at 6 p.m. and said, "Hey, there isn't even a watch out yet. We're in a moderate risk. When are the severe storms going to happen?" And we had to tell them, well, the threats, we've been saying the threat's not going to happen until later. But that was a realization for us that we weren't making that very obvious. We were talking about the threat more than the timing. And this emergency manager had their emergency operations center staffed for 12 hours already at the time. And now everyone's fatigued, and now the event's getting ready to start. And so if we can really help with this timing information, that's a great way that we can help with decision support for field offices, for emergency managers, and the rest of the weather industry. So one of the other things that we've been doing that's a little different, so we've always done mesoscale discussions that cover these smaller areas than our more broad mesoscale discussions. That's always something we've done in the past, but there has been a renewed focus recently to try and do a little more, put a little more of this type of information in our mesoscale discussions. Here's some of them back from March 3rd, 2019, talking about this area here in Southeast Alabama. This is, of course, where the Lee County, Alabama tornado occurred, with the unfortunate 23 fatalities that day. And here's another one from that day. This was a phenomenal MD by Brian Smith, just talking about the strong tornado potential maximizing. And this is, I believe, an hour or two before the tornado formed, and it moved through all the mobile homes in that area. So these are the type of things we're really working to do more often. And the state of the science is getting to the point where we can start to see these things, a couple hours in advance, and start to give some advance notice to some of these communities, and kind of filling that gap between the watch and the warning, which is a lot of what Facets is trying to do. And so another thing that we've been doing with that, you may have seen a couple of these MDs that Brian Smith has done as well, with some explicit tornado guidance with wind speed probabilities and things like that. And that's another idea of, is this the type of thing that could help bridge that gap between the watch and warning space? And that's based on some of the research that he and Rich Thompson have done, where they looked at the rotational velocity in thunderstorms when a tornado was occurring, and then compared it to the data points and what wind speeds were being observed in that area. And so here's all the data points there, but basically what he showed is that, we've got our current base tier, considerable tag, IBW, and catastrophic tag, which those ones are these gray circles there, and there. But he kind of showed that there's the possibility of some additional discrimination possible on the high end. And that was part of what his research showed there. In this chart here, basically, using STP and VROT, you can kind of see these different tiers of categories. And really, you've got the extreme category up here. using things such as, population density was a big one for that. If you want EF5 damage, you really need enough population density to have enough structures to actually realize that damage in those cases, which we've seen in plenty of tornado events that did not get the rating that was supported by Doppler radar from the field. So switching directions a little bit, kind of talking about how SPC outlooks can move into impacts and how we might move into that realm with what we're doing with our probabilistic forecast. So this is some work that's being done by Patrick Marsh, Race Clark, and Summer Erickson. And so here's a population density map of the US. And obviously population density varies across the country. Out here in Nebraska, it's mostly rural. Here in Oklahoma, this one's a little more spread out. Middlefield, Ohio here, for example, it's all higher population density. There's not much rural areas. So for example, a tornado in that area, it's going to hit something that's be very difficult for it to be out in an open field. So we know these things matter. And it, obviously for the most part, it gets more and more dense as you go east in the CONUS. And so not all high risks are created equal. Here's a great example of that. Take April 14th of 2012. There's actually these two high risk areas. On that day, the population that would have been exposed to that, basically the worst of the severe weather that day was right around 2.4%. There's a 2.4% probability that 1 million people could be exposed. However, on April 27th of 2011, that probability is at 91%, just because it's in a different part of the country. The outlook size is pretty similar, but in a different part of the country, you've got basically a 91% chance that 1 million people are going to be exposed to this event. And then for 5 million, the 5 million probability is basically the same as the 1 million probability was for this day out in the plains. And so we know that matters. We know that that has impact. So what can we do with that data? And so here's another way of looking at that. The tornadoes by F scale. So if you're looking at strong tornadoes, let's say F3 and stronger, that's basically right in here. Yet basically 6% of the tornadoes are in that area, except 86% of the fatalities occur in that area. So we need to improve our forecast of the intensity, because that's obviously what matters. It's the high-end tornadoes are the ones that are causing the most fatalities, they're causing the most damage, that cause the press coverage. And so those are some of the things that we need to do. So I took this from Race Clark's presentation that he did at NWA here a couple weeks ago. And he's talking about some of the work that's being done in HWT to possibly do some of this. So let's take a look at this area here. So we've got 10% tornado probabilities, and we have a 10% hatched area. So what does that mean? Well, that would imply that if there's 10% coverage of tornadoes and 10% coverage of SIG tornadoes, that all the tornadoes in that region would be significant. Now, obviously, that's not what the forecaster is trying to say, but that's a limitation of where we're currently at. And what we see is that just simply our probabilities itself really do say something about the tornado probability or the forecast probability of significant tornadoes. And so you see here, a 10% tornado area has about 5% SIG-TOR coverage, but up to 45%, you're up to 35% SIG-TOR coverage there. And so that kind of brings out this idea of, looking at where we're currently at. So right now, so if you aren't familiar with it, so this is basically no tornado outlook. There's tornadoes outlooked, but no hatched area. This is a hatched area, and the double hatch is a high risk. So it's 30%. Tornado probabilities are higher within a hatched area, and that's what this double hatch is referring to. But so on these high risk days, 25% of all tornadoes are significant. So on these high-end days, we do have discrimination there. Non-high risk days, but with a hatched area, 15% of the tornadoes are SIG. So, okay, so when we have hatched areas, they're doing a pretty good job there as well. When there's no hatched area, we're down to 6% of tornadoes are SIG. Oops. And then when we don't have a hatched area, or when we don't have tornado probabilities at all, only 2% of the tornadoes are significant. So for the most part, they're being covered pretty well by our outlooks, but how can we better, display this intensity information? And that's what we're looking at. So in HWT this year, they looked into this idea of having a hatched area and a double hatched area. where the double hatched area would be drawn for environments that are strongly supportive of high intensity severe hazards. So essentially a high fraction of your reports are expected to be significant. It's generally, I mean, obviously it's going to be in an extreme cape and shear parameter space, very favorable storm mode, basically think high risk type events. And so this is an example from May 20th, 2019. We all know the day kind of ended, was a little underwhelming for what was expected, looking at some of the soundings and things like that. But it was fortunate that they were running the experiment here during that time period to have an opportunity to kind of use these probabilities. And so then this hatched area around it, that area in this realm, this is a different hatched than the current operational hatch. That's an important thing to remember here, is that this is kind of using something different rather than a threshold of 10% coverage of SIG. This is more talking about some reports are expected to be significant. You've got a pretty high end Cape Shear parameter space, not the extreme that we had before, but in favorable storm mode. So, it's pretty good, but it's not, okay, we're worried about, high risk type event going on. I won't go through this whole table, but this is essentially the idea of how it was broken down. You're no tornado, you're non-hatched, you're hatched, and you're double hatched. What type of things you should be looking for? This is what was being used by the people there at the HWT. So here's another example. This is looking at a hail outlook. And so in this hail outlook, there are, in this area here, it's basically saying, okay, that, we think there's going to be numerous storms with some large hail. Well, down here, we don't think there's going to be as many storms, only a 15% probability, but the double hatched says the storms that do form would generate very large hail, and that'd be the concern. And that's what happened on this day. A large proportion of the reports down in this area were majority SIG, whereas up here, there were a lot more reports, but less of them were SIG. There were still some SIG, but less of them were SIG. We're down here, majority of the reports that got, almost half of them were SIG. And so that's, that was a great case for using that for hail intensity there. So jumping back into, kind of the impact forecasts with that FEMA partnership, this is a weather generator that's Patrick's been working on. So essentially simulating tornado days and using basically an ensemble approach of what all the possibilities are, and then using it based on underlying GIS layers of impacts. So for example, if you run a simulated tornado day, one time you get 114 tornadoes exposing 304,000 people, all these different possibilities as you go down through the list. Well, on 3 different high risks, you can have widely different outcomes. April 27th, 166 tornadoes, 316 fatalities. May 24th, this is a high end day, but there were only 48 tornadoes compared to April 27th, 18 fatalities. November 17th, 74 tornadoes, 8 fatalities. So there's a wide range. Every high risk isn't created equal. There's a wide range, and that's part of the idea behind it. So by running 1,500 simulations, you can get the tornado count potential. You can run that to figure out population exposure possibilities. And this is using each of these outlooks. This is using the April 27th outlook, the May 24th outlook, the November 13th outlook. So you can see it really, you have a lot longer tail on the high end here on November 17th. Probably partially because Chicago metro area was included. So when there were a lot more tornadoes in the tornado simulator that went through the Chicago area, you would have a lot more on the high end. There's a lot of impacts into that. But the idea behind it is then you can quantify the likelihood of impacts on schools, hospitals, mobile homes, critical infrastructure, the stuff that FEMA really cares about. And so, here's a case where you could say, all right, well, based on this outlook, let's say for power substation or population exposure, mobile home exposure, for example, your realistic best case scenario, only 121 mobile homes are exposed to a tornado track. Whereas, all the way up to your realistic worst case scenario, you have almost 5,000 mobile homes exposed. And what this means by exposed is basically, I believe it's a 2.5 kilometer buffer on each side of a tornado track. So essentially, you were either in a tornado or very close to one, is the definition of exposure on these. And so most of you are probably familiar with our forecaster tools, so I'll just jump through these here pretty quickly. Sound and climatology page, that's something that we use a lot when we're looking for just how anomalous an event might be. If you aren't using the href yet, I highly recommend you do. We use it daily. We use it a lot for just because, one of the toughest things is if all you're looking at is the latest run of the HER, you could be locked into one solution and not realize the ensemble approach of the rest of the convective allowing guidance. So really looking at it from an ensemble approach is incredibly helpful, and it's a very helpful way for us to look at the CAMs from the SPC. So if you aren't on here frequently, I recommend getting on here and just playing around with looking at a lot of these different storm attributes, the individual members. It's a great way to look at kind of an ensemble-based look at the environment. So you don't, we all know you're looking at an individual NAM run and you've got STP or supercell composite of, 30 STP and 80 supercell composite. It's not realistic, but when you have an ensemble-based approach, it washes out a lot of those extremes and you get a little more realistic view of what the environment might look like. The HER browser, this is another great page that was developed by John Hart. This is a great way to look at each of the new HER runs. He's got each of them here with the hourly time steps. You can overlay things like CAPE and stability, or CAPE, shear, things like that. So you can see, okay, this run was forming more storms than the previous few runs. What changed? Are the dew points higher? Okay, well, how's that look based on observations? Those are the type of things you can really dig into deeper when you look at it. I won't touch on this too much. The Total Environments browser. Here's an internal web page that we use all the time for looking at bad wind profiles, because it's, now that we don't have a profiler network out there, this is probably the best way to see real-time, shear analysis, especially in the low levels, looking at deep layer shear, et cetera. This is a great page that John Hart has developed that we use as well. Another internal page that we use here, this great page by John, the model comparison page. We use that to go through past runs so we can see, if we're doing an extended range, day 4, day 5 outlook, okay, well, and maybe it's your first day on, okay, well, why'd the forecaster put a risk area there? And you can go back and look a couple runs. Oh, okay, the trough, was a little farther west. Okay, well, I just need to adjust it, and those type of things are really helpful. Or also consistency in a pattern. Okay, well, I've been seeing this now for, looking back 3-4 runs in a row, it's been showing this. Okay, I think it's time to put the probabilities in. So this has been a hugely helpful page from John for the forecasters here as well. So kind of wrapping up here, what are some of the things that we're working towards next? Well, the next progression is probably going to be issuing a day 3 outlook twice a day. So currently we only issue the day 3 on the night shift, and so it updates one time, sometime in 8, 9 Z in the morning time frame. But now we're looking that probably there'll be another issuance sometime mid-afternoon, kind of like the day 2 is right now, where we update it there. And then also when moving forward in time to the day 2 period, we've already started, if you've seen in the day 2 outlook with the table of the hazard probabilities, we'll be going to a full day 2 probabilities that look exactly like the day 1, where we explicitly draw it all out. That'll be coming here soon, in not too much longer. There's some complications with the AWIPS 2 transition, but that'll be coming out here in not too much longer. And then, I talked about the short range day 1 probabilistic outlooks using the temporal guidance, but then also, more frequently updating the day 1 outlook to reflect some of those changes. Those are some of the things we're working on as well. And then also, one of the things that we get a lot of questions or consternation about as well, the slate risk line, is barely into Alabama and we don't think it's going to be there. Well, the reality is if you're right along the line, it's fluid. It doesn't go from 5% to 15% in 1 mile range. So we need to really show more continuous probabilities. And so Chris Carson's has been working on that. And this is what we mean by continuous probabilities. So it basically washes it out, and you have a 8%, 5%, a 3% contour line as you go across here, rather than just explicit, especially for hail and wind, 30, 15, 5. Well, there's a lot of range in between there. So you can see if you're halfway between the 15 and the 5, well, now you're probably going to show up at like a 10% probability, which is what it was showing all along. But until you actually visualize it with these continuous probabilities, you don't get the opportunity to really kind of see it out like that. So that's something that we already have running internally, and that we might be exploring, sharing it externally at some point, and is something that we're working towards here. So with that, I will go ahead and take any questions anyone might have.
Yeah, it looks like we have some in the chat here. If you ask some, feel free to turn your mic on and kind of expound upon them. But Kevin asks, there seems to be a good deal of confusion on the names of the outlook risk areas. Is there any work on this?
So that's something that we hear a lot. And the reality is the words, for example, slight, moderate, high have been words that we've been using for decades now. And so there's been such an effort to train people on what these mean. And there has been some talk with social scientists, are there better words, things like that. But the bottom line is when you get down to it, if we change to something new, then there's going to be a whole new learning process for the new thing. There's no perfect words, and I think that's part of the issue. So that's a constant conversation we're having with social scientists, but there really hasn't been any, there hasn't been a smoking gun where like, well, if you change to this word, it becomes suddenly more clear. It's been such a muddy area that it's a conversation we're always having, but there's no, say, specific efforts to change anything like that.
Okay, sounds good. Yeah, I think especially since, the broadcast community definitely, they do use the same language, and then sometimes I find they may, alter it a little bit, so the public can really get a good grasp of, what it means. So that's good that the conversations are still being held there. And then it looks like Kevin also asks, is there any plan to make the NFLOW VWP viewer public?
I could certainly see why there might be desire to, because we love using it. There's some complications behind whether or not that can happen. And yeah, I'm getting Patrick's in the room, and he'd be partially in charge of whether or not that happened. But it's things like maintenance on the web page, and the more tools we add to our web page, like for example, mesoanalysis is used by so many people, but that requires a lot of maintenance. For example, if it breaks on a day when Patrick's not here or John Hart's not here or Matt Mosier's not here, it's pretty much broken until one of them comes back. I mean, there's not we don't have a national NCO structure that's supporting all these projects. It's a couple experts in the office. And so yeah, so with not, those are non-operational products, and if something like NFlow were to ever come out, it would be in a non-operational realm. But that's our hesitation with releasing more and more of those type of things, is just the maintenance, and because a lot of times it's forecasters who are doing it too, and forecasters, obviously the first priority has to be the forecast and the operations, and as well. So I wouldn't count on seeing it anytime soon, but that's not saying that it's not something that we might be able to have public at some point in time.
Okay, thank you. And then one of our board members actually asked a question here, Stefan did. Where do you see the interface between the WFOs and SPC in that period between watch and warning? The operations proving ground did a meso-analysis boot camp and was trying to figure out how this would work.
Yeah, so I think that's going to be the key, is how we deal with that communication, because the thing is, right now we've got a watch, an MD, and then a warning that comes out, and pretty much it's, we get on a conference call with the local forecast office when we've got the watch coming out, and we're going to, hey, here's the counties we're thinking about, what do you guys think, adding any counties? Boom, the watch goes out, and generally from that point on, the conversations that we have with the local forecast office are generally, hey, can we clear this county? What do you think about clearing this area, et cetera? It's more maintenance of the watch, and I think something that can be improved in that time frame is a little more active communication. I think one thing personally we've been focusing, or I should say that I've personally seen here that we've been focusing on, is trying to encourage more frequent watch MDs. Because the thing is, if we have something to say, if say we're having a conversation in the office, oh yeah, you see that boundary in that area, or oh hey, you see winds are backing through that area, it has us concerned. We have these conversations a lot that don't always make it to MDs, and or on the opposite side, sometimes it's like, well, it's been 3 hours since we've issued an MD, but I don't know what I'd say. Everything's looking about the same. And the feedback we've gotten time and time again from, especially like broadcast meteorologists who have been on the air for 2 to 3 hours and haven't had time to sit down and do the mesoanalysis themselves and things like that, is that the more we can get that information out, the better. And so I think better, communicating some of that just in general through the MD would be a helpful process, doing more frequent MDs for, smaller areas. But then also, specifically with the WFO and the SPC, I think, having those conversations with the local forecast office and just having a little more open, open conversation, open dialogue between us and the forecast office is always going to be helpful when we're going through that period. And so so I'd say that's an area of expertise to improve on. And things like the operations proving ground, working on that mesoanalysis boot camp is a great step moving in that direction, because Rich Thompson was there, Ariel Cohen was there, presenting for that. Corey Mead, I know, was there a couple of days. And so the experts here at the SPC are doing that mesoanalysis every day. We're doing 2 to 3 surface charts a day. Most days we're really dug deep into the data. And so to have some of the experts who've been doing this for 20 to 30 years, helping out with some of the, especially the newer forecasters and the forecast offices, to show some of that expertise and how we can, work together to be on the same page. I think that's really helpful. And so that's been a great process as we're moving forward.
Yeah, awesome. Yeah, it always mind boggles me when, sometimes we don't, give another office a call or give SPC a call, and it's just like all it takes is a phone call. I remember when we visited you there, you said you don't really get public calls, so it's much easier for you guys to kind of get calls and different things like that. So yeah, Kevin says yes to the more frequent MDs. He's a fan of that. And then Zach Hyris here says, near the beginning of the presentation, you showed heat maps of ML Cape and Shear for tornadoes and SIG tours. He believes he's seen them for SIG hail and wind, but have never tracked down a web page or publication for those to be available. Are those internal, or are they publicly available for the tours and SIG tours?
I know we use those graphics in a lot of our, just a second here, I'll ask Patrick about it. The heat maps of Cape Shear, are those public on our website? Yeah, I didn't think so. So yeah, so Patrick confirmed. Yeah, so we don't have those public on our website. We use them in a lot of presentations, but as someone who's working with Patrick on kind of revamping our WCM webpage, that's the type of thing that will most certainly be on there in the future. We're looking maybe a year from now. We should hope to have that revamped with a whole new data system, with all the data displayed in a lot easier to manage, easier to track format. But if you're ever interested in any of those things, send an email to Patrick, patrick.marsh at noaa.gov, and he's always more than willing to ship it off. Any of these things you see from our presentations, Patrick's more than willing to send them to you in an email anytime you'd like, and he's pretty responsive to email.
Cool, sounds great. All right. Yeah, does anyone else have any other questions? Feel free to type it in, or you can unmute yourself and state your question. So I kind of have a little question since I'm here in the Southwest. We probably saw from Twitter and Facebook that, there was a tornado that happened north of Phoenix and different things like that. They had a pretty wild day out there in Arizona. Then I think Tucson issued another warning yesterday. Is there any kind of difference in procedures when you're forecasting, kind of a big risk area for places that don't usually see it, such as, Arizona or different things like that?
Yeah, I mean, pretty much no. It would be the basic answer, because the physics of the atmosphere are the same everywhere, and really we start our forecast analysis process pretty much at the same point, regardless of where we are in the country. Now, the place where that does cause some challenge, and to say that we never adjust to this would be probably inaccurate, because we're human, but thinking about it from an impacts perspective. If we know that there are going to be thunderstorms, widespread supercells in central Montana versus widespread supercells in, the I-95 corridor of the mid-Atlantic, we know the impacts are going to be far greater in the mid-Atlantic. Now, our forecast is a science-based forecast on the probabilities of, 50 knot winds, of 1-inch hail, and the possibility of tornadoes. And so we don't adjust our forecast for impacts, but that is a challenging part because the impacts are far different. And that's why I think some of the work that Patrick's doing there with doing the tornado event simulator and things like that is hugely crucial, because that is a challenging part for us. When we come in the next day and we see, there's 300 dots in the Carolinas or something, and it was just a squall line with 40 to 50 mile per hour winds, but it blew down, thousands of trees. And so that is a challenging part of us, balancing the science with the impacts, and really, focusing on the science and letting the local forecast offices, talk about those impacts, or, I remember a case in West Texas, there's a day when we had a ton of blue dots of wind reports from the mid-Atlantic, and there were no measured wind that was severe from any of the ASOS sites that it went over. It was 45 to 55 mile per hour winds. And then, then there's this marginal risk with this one or two lone supercells out in the Texas Panhandle that had 87 mile per hour wind gusts coming out of them. And so it just shows how, it's totally different in every part of the country. I wouldn't be surprised if Amarillo wasn't even staffed up that day, because those are those are the type of things that happen fairly often, in that part of the country.
Yeah, it's definitely different, especially I know that here in Southern California, a 30-mile wind gust is probably nothing to most people, but here it can knock down a whole tree. So it really depends what happens there. Looks
Well,
like,
and I know from my time in Portland, even thunderstorms out there are a big deal
yeah,
because they don't get a lot of thunder. And so
right.
I remember, having that expertise working at the local office. When I'm working on the thunder line for the day one outlook, I'm always paying extra close attention whether or not I put the Portland metro area in there, and that goes for any of the big cities on the West Coast, because with how infrequent lightning and thunder is there, it's definitely a big deal. Even if there's not any severe weather associated with it, just the fact that there's thunderstorms going on could be a pretty big deal. I think I've heard something crazy, traffic accidents go up over 1,000%, the LA area during thunderstorm events or heavy rain events, and so
Mhm.
it's a totally different ballgame out there.
Definitely. And then it looks like Kevin has another question here, stating that the probability products are amazing, but are there concerns about those products in the hands of social media forecasters? Won't 40% chance of a tornado at point X and an hour and a half from now going to cause trouble?
That would certainly be part of the concern, and that's why it's internal for now. And it's not, we don't have a March timeframe that we're going to be releasing to the public, because we see the primary mission of this right now as being a great helpful tool for local forecast offices to explain the temporal information, and then also for the emergency managers who can get that information through the local forecast office. So figuring out how the best way is to display that information and share that information once we do go public with it will be very important. And that's, yeah, your concern there is one that is very well known here, and is part of the reason why we're always slow and reluctant to release new products until we're confident that, it's that, first of all, it's good, and that it's, and that it's not gonna break one, and that two, the probabilities are good, but then also that, once it goes out, it's not going to be misused. And that was part of the hesitation with mesoanalysis. People were worried about mesoanalysis, and now mesoanalysis is, probably the top thing people come to our website for. And so there are some, eventually you got to take the plunge, because sometimes it can be the most useful thing. But we share the same concerns.
All right, sounds good. Thank you so much again for doing this presentation with us. We are the AMS BOGM. You can find us on Facebook and Twitter. This will be recorded. This is a recorded presentation, so we'll probably post it within the next few days here. But yeah, thank you again, and I hope everyone had a good time. Thanks, Evan.
All right, thank you, Adam, and thank you, everyone, for joining.